In this problem, we have two capacitors connected in series and then connected to our power supply. We want to know the charge on the second capacitor, in this case the 10 microfarad capacitor. So if we just draw ourselves a little sketch here, our circuit diagram, we have 4 microfarad capacitor connected in series with a 10 microfarad capacitor, then connected to our 12 volt power supply. And we want to know the charge for this 10 microfarad capacitor. So before I can find the charge of this capacitor, I need to know what is the total or the equivalent capacitance for the circuit itself. So because these are in series, I'm going to do that 1 over the equivalent or total capacitance is 1 over 4 plus 1 over 10. And so if I do 1 over 4 plus 1 over 10, but then I want to take the inverse of this answer so that I can solve for the equivalent capacitance. Then I get an equivalent capacitance of 2.86 microfarads. All right, so if that's my equivalent or my total capacitance, the 12 volts is the total voltage for the entire circuit. And what I can do then is say, okay, well the total charge for the whole circuit is the circuit's voltage times the total or the equivalent capacitance. So this is the whole circuit here. We know its entire capacitance, we know its entire voltage. And so if I take those 12 volts times this capacitance we just found, so I'm just going to multiply my answer I had just a moment ago by 12, then the charge for the entire circuit is 34.3 microcoulombs. And what's important now is because this is a series circuit, that these two capacitors have exactly the same charge, which is the total charge for the entire circuit.